Kari, Stephen, and Ben. We also have 4 mechanical engineering team members who have worked with us this semester. Our corporate sponsor is Mentalix, which is a company that takes paper fingerprint cards, as you see here, and they scan them to make electronic copies, which are much more easily searchable. This could be used by the DMV or for criminal investigation or any number of applications where fingerprints are used. Mentalix has several types of scanning systems, which are all FBI approved, and they would like to update one of their scanner types to a newer model, which does not have an automatic document feeder or ADF that is compatible with it. We would like to provide them, so they would like to transfer to the old ADF to a robotic solution for this feeding process. We would like to provide them with this robotic arm solution, as well as increase their throughput in 2 ways. First, we'll increase the throughput by increasing the capacity of the input and output tray. This is their old ADF on top of the scanner here, and this is our new model. So as you can see, this would hold maybe 20 to 40 fingerprint cards at a time, and our new design, we hope to hold 1,000 to 1,500 cards at a time. We also hope to increase the throughput by running the robotic arm continuously, such as during off hours on nights and weekends. So for example, an employee could be ready to go at the end of the day. They fill up the input tray with a full stack of cards and head on home. The next day they can come back in the morning, the stack of cards will be in the output tray, and all of them will have been scanned. This is the robotic arm that we actually have purchased already, and we have at our table if you would like to come by and see it. Here you see it picking up a thin piece of plastic with a syringe vacuum gripper, which unfortunately was unsuccessful in picking up the much more porous paper. We do, however, have a design that has been successful. It is this T PVC pipe you see here with a suction gripper connected to the lower opening. We were running compressed air through the top line to utilize the Venturi effect. So it creates a pressure differential, and then it creates a vacuum because of this pressure difference. In this next semester, we'll take this compressed air design and compare it with vacuum pump models, select the best one, and Kari and I will work on programming the robotic arm movement sequence. Stephen and Ben will work on a top program to interface with the robotic arm and the scanner through a computer. And our mechanical side of our team will work on finishing the design for the white background of each scan and designing and building the mounting or cradle system to keep each part of the system in place. And by the end of senior design 2, we'll be able to hand our robotic arm solution design to Mentalix to be FBI approved. Thank you for your time. I can now open up the floor for any questions for me or my teammates. Yes?
How do you prevent the suction on to prevent damage to the fingerprints?
The gripper we're using is just a rubber suction cup. As long as it stays clean, I don't foresee any damage to the cards.
Yeah, we presented this solution to our corporate vendor, and we haven't had any concerns so far, so we don't have a concern at this point.
Yes.
Do all the fingerprint cards always come right side up, or do you have to figure out how to decide whether it's right side up or upside down?
That's a good question. All of the fingerprint cards are individually barcoded. So Mentalix, when they receive them, they put a barcode on each one, and they can be oriented anyway after that. For duplexing, if you wanted to duplex, you can simply run the stack once, flip them over, and run it again. And because they're all individually barcoded, there won't be any mix-up.
You mentioned that you can leave a stack of cards in there, say 5 o'clock on a Friday afternoon, and come back to Monday morning. Do you envisage any malfunctions or card reader errors that you can come in on the morning and have 2 more clear the rest of it still sitting there?
Our biggest problems so far have been in picking up just one card. In typical scanning systems, you could have paper jams, and
go through in a certain amount of time?
We've done some rough calculations, if we can get our sequence, under a minute, we're looking on a 24-hour period, being able to run a stack of around 1,500. That may change, depending on what our final sequence becomes, but our throughput is severely, improved.
The previous scanner feeding system took about 30 seconds per scan, so we need to ultimately have the same time on us.
From a time study, where's the most time coming from in your estimate for how to perform?
Each scan takes around 20 to 30 seconds, I believe, just for the scan alone. Also, we'd like the arm to move as quickly as possible, but we would not like to shake paper loose, lose a good contact. It's something that we're going to have to test this next semester to see how fast we can run the sequence, how quickly we can get the scan process as well.
If you find that you're not executing fast enough, what options do you have?
I'm not entirely certain.
So if
What a
you-
concern would be for not running.
If your customer wants you to scan in 15 seconds and you're at 30, what options do you have to
What
increase your
what
time?
options we kind of do have, we have like, an option of changing like what the pressure is, that like maybe coming out of the compressor or, pretty much if we're gonna go for a suction cup, a DC vacuum suction solution. So we can try to increase, vacuum so that it'll hold so we can, pretty much allow it to run faster. But there is kind of cost, and we have talked that it does, there is the possibility of picking up like 2 cards at a time. So it's, so next semester, we're gonna try to do some tests to see like, pretty much what, pressure range would be a good range.
We can also modify the speed through the real software of the actual device. In terms of time, the 30 seconds we can't impact because there's a resolution requirement for the FBI that they have to maintain. So that 30-second window will always be there. In terms of timing or movement of the device, we can't control that through the real software.
Also, overall, the goal of the project is to provide feeding solution. Decreasing the time would be great, but it's not a primary goal.
We tried different routes, like plastics, or it's only like meant for particular card that.
For this design, it's meant for this particular card, which is a 3x8 square. They have some other scanning systems if they receive very different types of cards or fingerprints. So it's not necessary to test it on other materials.
Especially if the material is not perfectly black, and you're relying on a vacuum, so.
But we will test other options. We are in the process.
Are you scanning or taking a picture?
Scanning. So what we're doing is taking a card from an input tray with the suction cup, placing it over top of the scanner, placing it over there, then communicating with the computer to scan the document, and then place it into the output tray.
The efficiency in taking pictures, or is that not?
You can't improve the efficiency of the scanning because, as I said, FBI has certain requirements for resolution, and that 30-second window will always be there just because
It's an FBI requirement. They
so
They-
we
they
can't
don't like
impact that.
pictures. Yeah, they might change their mind in a couple of months or years. But they have a